Imagine standing in a Roman street in the height of summer, somewhere between Hispania and the sands of North Africa, where the temperature climbs past 45 degrees Celsius. The stone under your sandals is hot enough to blister skin. Every breath tastes like dust and fire. Now imagine stepping through a single doorway into a private Roman home and feeling the temperature drop almost instantly, without a single watt of electricity, without a machine of any kind. Over 2,000 years ago, Roman engineers built entire houses, entire cities, that could outcool a modern air conditioner using nothing but stone, water, and physics. How did an empire without electricity solve a problem we still struggle to solve today? Let's step through that doorway. By the height of the Roman Empire, cities stretched from foggy Britain to the blazing deserts of Egypt. And in the hottest provinces, Hispania, North Africa, the southern coasts of Italy, summer wasn't just uncomfortable, it was dangerous. Food spoiled within hours. Public fountains ran dry under the sun. And the average Roman home, built from stone and packed close together on narrow streets, could trap heat like a kiln. There was no fleeing the empire. So Roman architects, engineers, and everyday builders did something remarkable. They turned the house itself into a machine for staying alive. The first weapon against the heat wasn't a device, it was a floor plan. At the center of a wealthy Roman home, the domus, sat a room called the Atrium, open to the sky through a rectangular gap called the impluvium. Beneath that opening sat a shallow pool, the impluvium, collecting every drop of rain that fell through. But that pool did something else entirely. As hot air pushed down through the impluvium and touched the surface of the water, it lost its heat instantly through evaporation, the same physics your body uses to cool itself when you sweat. That cooled air sank, spread through the surrounding rooms, and pulled hot, stale air out through doorways on the far side of the house. It was a constant, silent current. No fans, no motors, just water, air pressure, and geometry. Wealthier homes pushed this even further with a peristyle, a colonnaded garden courtyard, often centered on its own fountain, funneling a second stream of cool, moist air through the home. And the walls themselves were part of the system. Roman concrete and stone were thick enough to act as thermal batteries, soaking up the punishing daytime heat and only releasing it long after the sun went down. Roman architects even wrote the rulebook. The engineer Vitruvius described exactly how a house should face the sun and the wind, depending on the climate of the province it was built in. This wasn't luck. This was applied science, in an empire that had never heard the word thermodynamics. But a single house wasn't enough. Rome cooled entire cities. Roman aqueducts, some stretching over 50 miles from mountain springs, fed a constant, unbroken flow of water into public fountains scattered through every district. That water wasn't just for drinking. Every fountain, every basin, every public nymphaeum was quietly evaporating, pulling heat out of the air around it, all day, every day. And when the heat became unbearable, Romans had somewhere to go. The baths. The thermae were a cornerstone of daily Roman life, and their coldest chamber, the frigidarium, offered a plunge into cool water so central to Roman culture that entire cities were built around the ritual. Multiply that by public fountains on nearly every street corner, and you have something no single building could achieve alone. An entire city working together as one enormous silent air conditioner. For the truly wealthy, there was one more trick. Go underground. Roman villas built into hillsides sometimes included a cryptoporticus, a long vaulted gallery buried half beneath the earth. Down there, the temperature barely moved at all. Soil is an extraordinary insulator. Deep enough underground, it holds a nearly constant temperature no matter what's happening in the sky above. The writer Pliny the Younger described retreating to exactly this kind of space in his own villa during the worst of the Italian summer, reading and writing in comfort while the world outside baked. It's the same principle a modern wine cellar uses today, except the Romans were doing it 2,000 years before refrigeration existed. If cooling an entire city sounds impressive, what the wealthiest Romans did next sounds almost unbelievable. They chilled their drinks, with snow carried down from the mountains. Runners and wagons hauled snow and ice from the slopes of the Apennines, racing against the sun before it melted completely. Once it reached the city, that snow was packed into deep straw-insulated pits, underground chambers designed for exactly one purpose: slow the melt, for as long as physically possible. The same principle a modern insulated cooler uses, built from nothing but a hole in the ground and a few feet of straw. Writers of the time couldn't decide whether to be impressed or disgusted. The philosopher Seneca openly mocked the extravagance of drinking wine chilled with mountain snow in the middle of a heat wave. And yet emperors did exactly that. Snow-chilled wine, snow-chilled fruit, treats crushed with ice that were, essentially, ancient sorbet, more than 1,000 years before anyone in Europe called it that. In a world with no refrigerators, some Romans were eating dessert made from mountain ice in the height of summer. And when tens of thousands of Romans gathered under the open sky, engineers had an answer for that too. The Colosseum and the great public squares of Rome were fitted with the velarium, a massive retractable canvas awning rigged with ropes and pulleys and operated by sailors from the Roman navy. Pull the ropes, and shade swept across an entire amphitheater in minutes. It was climate control on the scale of an entire city block, centuries before anyone imagined a retractable stadium roof. Today, we spend enormous amounts of electricity every single year just to keep our buildings cool. But 2,000 years ago, Rome cooled homes, baths, and entire public spaces using nothing but water, stone, airflow, and geometry. And it turns out, architects haven't forgotten. Courtyard housing, thermal mass walls, and passive cross-ventilation, principles first written down by Vitruvius, are being rediscovered right now in sustainable building design across hot climates worldwide. The most advanced cooling technology of the future might just be the oldest one we ever abandoned. Would you trade your air conditioner for a Roman atrium and a snow pit? Let me know in the comments below. If you found this fascinating, hit that like button and subscribe to Epics Revealed for more incredible deep dives into history's greatest engineering secrets. Thanks for watching.